Let's look at another example now. Let's say consider sine. Okay, sine. It says calculate the first 8 derivatives and then use the pattern to calculate the 75th derivative. Okay, let's first do the first 8 derivatives and let's see what we can come up with. So, all right, what we have here, start with y equals sine x, okay. What about y prime? The first derivative, okay, you know that's cosine, right? We memorized that, or you're on your way to memorizing that. Y double prime, okay, what's the derivative of cosine? Okay, again, you're memorizing this, or you're very close to it, is negative sine x. Okay, so triple prime is the derivative of the second derivative. All right, okay, so we have a negative 1 times sine. So we can use the constant multiple rule to say, okay, negative 1 times the derivative of sine, but the derivative of sine is cosine, so it's negative cosine. Okay? And now the fourth derivative, in fact, I'm going to put the fourth derivative up here, just you'll see why in just a sec. You know, the fourth derivative, we notate like that. We drop the prime notation. The fourth derivative, okay, we take the derivative of the third derivative. Now, okay, we have negative cosine, so we take the derivative of cosine and make it negative. But cosine, the derivative is negative sine. So we have negative sine, which is just sine x. So what do you know? Like we're back to our starting point. And if we take the derivative again, this will be the fifth derivative. Okay, the derivative of sine is cosine. If we want the sixth derivative, what's the derivative of cosine? It's negative sine. If you want the seventh derivative, what do you see? Okay, you do the derivative of negative sine. We already saw here the derivative of negative sine is negative cosine. And then what you see is we have this repeating pattern. Every 4 derivatives matches up. I mean, you can do it another set of 4. What about if you want the 8th derivative? Y to the I said y to the 8th. That's not y to the 8th. That's the 8th derivative of y. Okay, you take the derivative of the 7th derivative. Well, okay, so you have negative cosine. So you take the derivative of cosine and then make it negative. But the derivative of cosine is negative sine. So you have double negative sine is just a positive sine. And now we're to the beginning. What's the derivative of sine? Well, it's cosine. What's the derivative of cosine? It's negative sine. What's the derivative of negative sine? Well, it's negative cosine. So I hope you sufficiently see the pattern here. Now, sometimes it's hard to see, well, how does that translate now to the 75th derivative? But here's what I want you to see. Notice that every fourth derivative for 8 is sine. And now, sorry, I shouldn't say it that way. Every derivative that is a multiple of 4 is equal to sine. What about 5, or first? There's the first derivative, the 5th derivative, the 9th derivative. Those are all 1 more than a multiple of 4. So 1, 0 of course is a multiple of 4. 5 is 1 more than a multiple of 4. 9 is 1 more than a multiple of 4, 8. So all of the derivatives that are 1 more than a multiple of 4 are also going to be cosine. All right, what about second derivative, 6th derivative, 10th derivative? Those are all 2 more than a multiple of 4. The second, 2 is 2 more than 0. 6 is 2 more than 4. And 10 is 2 more than 8. So if you're 2 more than a multiple of 4, the derivative is going to be negative sine. And then in this last row here, you have the 3rd derivative, the 7th derivative, the 11th derivative. All of those are 3 more than a multiple of 4. Because okay, 3 is 3 more than 0, of course. 7 is 3 more than 4. And 11 is 3 more than 8. So 3 more than a multiple of 4, the derivative is going to be negative cosine. So all you have to do is figure out, where does 75 fall? Okay, like is it a multiple of 4? Or is it 1 more than a multiple of 4? Or is it 2 more than a multiple of 4? Or is it 3 more than a multiple of 4? That's all the cases there are. Because if you're 4 more than a multiple of 4, then you're just a multiple of 4. Okay? So if you want to like summarize this, I think what you can say is, basically you could say that f, let's see, 4n plus kth derivative of f is equal to the kth derivative of f. Again, okay, don't think about powers here. This is derivative notation. So what you have to do is ask yourself, what is k? Because if you have, and k is the remainder when you divide by 4. Okay, so if you have the 75th derivative, what is the remainder when you divide 75 by 4? Okay, think back to your long division. What is it? 18 or 19 goes in there. Let's see. 4 times 18 is, yeah, 72. So 4 times 18 is 72, and there, what, is a remainder of 3. So there is a remainder of 3. So in other words, 75 is 3 more than a multiple of 4. The multiple of 4 being what? 72. Thus, if you want the 75th derivative, f, the 75th derivative of f, is going to be equal to what? 3 more than a what derivative fits the bill for 3 more than a multiple of 4? Well, I think that was this last row, right? 3 more than a multiple of 4 was the 3rd derivative, the 7th derivative, the 11th derivative. So it's negative cosine x. Here we can do it again. What about here? Let's just too bad you're not in the classroom with me. At this point in a regular classroom, I would say pick a number, any number, like 1,000, tens of thousands, 10,000. Just pick a number. I don't care. Let's say f of here 238. I have no idea what this is going to be, but let's just take a look. Okay, basically we need to divide by 4 and see what the remainder is. So somewhere over here where there's some room, 4 238. Okay, so it obviously 4 doesn't go into 2, but 4 goes into 23. What, 5 times? That's 20. Then we subtract, and subtract right there. Subtracting in the wrong place. All right, subtract there, and we get what? 3. Drop the 8. And now how many times does 4 go into 38? 9. 4 times 9 is 36. Yeah. 9, 36. Subtract. We get a remainder of 2. So we have a remainder of 2. So we could say, here, I'm going to double check my arithmetic really fast. Let's see. 4 times 59 is 236. Yeah, remainder of 2. Okay, so we could say that 238 is 2 more than a multiple of 4. Thus what? Thus f, the 238th derivative of f, is what? 2 more than a multiple of 4. So that was like your going up here, the third row. The third row here. 2 more than a multiple of 4, that was negative sine x. The sixth derivative, the second derivative, the sixth derivative, the 10th derivative, those were all 2 more than a multiple of 4, so negative sine x. So, by the way, a very similar situation can be shown to be true for the derivative of sine, because sine and cosine are like this. They bounce back and forth between different signed versions of sine and cosine. So you can do the exact same thing with with cosine, where you can find some, the 150th derivative or whatever by following a similar pattern. Okay? All right, that's it for right now. If you have any questions, always feel free to reach out. I'll catch you in the next video.